Okay, so good morning, everyone. Today I'm going to present the study titled 3-Year Monitoring Study of Heavy Metal Fluxes in Middle Continent Farmland Soils. So here is the structure of my presentation. I will start with an introduction, then explain the objectives and methodology. After that, I will present the results and discussion. Finally, I will give my conclusions. So, let me start with a surprising fact. Most people think heavy metals in farmland comes from fertilizers or irrigation water, but this study found that over 70% and in some cases up to 90% of the heavy metals actually comes from the air. So this raises a critical question. If the air is the main source, how fast are these metals accumulating in our soil? And should we be worried? Okay, so why does this matter? Heavy metals like cadmium can lead and absorbed by crops from the soil. These crops becomes our food. So eventually, the metals can enter our body and affect our health. However, most previous studies only lasted 1 year. But rainfall, temperature, and farming activities change every year. So short-term data may not tell us the real story. That's why long-term monitoring over several years is essential to get the accurate picture. And so, to address the gap, this study has 3 specific objectives. First, to measure the annual input and output of 8 heavy metals in farmland soil. This metal includes cadmium, mercury, arsenic, lead, and others. Second, to identify which pollutant pathway is the most important. Is this the air, or is it the fertilizers, or is it the irrigation water? Third, to evaluate whether the current accumulation rate poses a future risk to our food safety and soil quality. So how did they do this? Look at the diagrams. On the left, the researchers used a mass balance approach. Think of the farmland as a box. This measured everything that goes in from the top, and that includes the atmospheric deposition, irrigation water, and fertilizer. And they measured everything that goes out from the bottom, and that includes crop harvest and surface node runoff. By subtracting outputs from inputs, we calculate next accumulation, how much metal stays in soil every year. This study was conducted in a 62 square kilometers agricultural and in North Guangdong. The map on the left shows the study location and the 64 sampling points. Okay, so let's look at the most important findings. Look at the pie chart on the left. This shows the input sources for cadmium. As you can see, 89% comes from the atmospheric deposition. Fertilizers and irrigations are barely visible. They contribute less than 10% combined. Now look at the bar chart on the right. This is from the original paper. The top pin box represents input, and the metal comes into the soil. The shorter blue bars represent output, metals leaving the soil. For every metal shown there, the input bar is much taller than the output bar. So what does this mean? It means more metal are entering the living. The soil is acting like a sink. is hold onto these metals and accumulating in them year after year. So let's see the discussion. What does this mean for? Let me give you some key points. First, I think since atmospheric deposition is the main source, the most effective way to protect our soil is cleaning up our air. We need to reduce industrial emissions and vehicle exhaust. Second, the next accumulation is real, even in this middle polluted area. Metals are building up in the soils every year. We cannot ignore this. Third, and the last one, interestingly, the graph on the left shows that theoretical calculations did not match accurate monitoring data were real. The R is less than 0.1. This suggests the soil has becoming buffering capacity. It can temporarily hold on to incoming metals and keep the total concentration stable. But this buffering is limited. It won't last forever. And let me conclude. The study confirms the atmospheric deposition is the dominant source of cadmium in farmland soil, contributing 80% of the total inputs. The soil is currently a net sink, meaning more metals enter the leaf. However, continuous accumulation will gradually increase soil pollution over time. Therefore, strategies should shift from soil reclamation, cleaning up after the pollution happens, to emission reduction, stopping the pollution at the source. In short, to save our soil, we need to clean our air first. Okay, so these three are the references I use for this presentation. The main paper is by Young and colleagues and published in Scientific Reports in 2026. Thank you, everyone. This is my presentation.